Welcome to another physics class. During our last lesson, our topic is energy transformation in mechanical system. And I gave two examples of mechanical system which we said we are going to explain. The first one is a falling object from certain height. And the second one is the vibrating simple pendulum bulb. In that our last lesson, we're done with the first example. That is a falling object from certain height. Now, we promise to move to this example 2, which is a vibrating simple pendulum. We want to show how a vibrating simple pendulum also can transform energy. Now, from the diagram on the board, let's look at the energy transformation in this oscillating simple pendulum bulb. This is the starting point. The pendulum will be displayed with angle theta from the equilibrium position. So when it deflates and the pendulum releases to oscillate to and fro. Now at point A and C, the energy at A will be equal to energy at C. That is, the energy here is potential energy. 1. Maximum PE, that is at point A and C. Why is it maximum PE? Because the potential energy deals with height. So we have maximum height, H. At the same time, as it's moving to and fro from potential energy to kinetic energy to potential again, it means the kinetic energy at point A and C, Ke, is equal to 0. Why? Because at this point A, the pendulum will be at rest before it is being released. At point C, at least it will rest minimum of a second before it go back to the original position. So that is why at point A and C now, the kinetic energy will be equal to 0 because the kinetic energy is energy at motion. Now at point B now, at point B, the pendulum will be at equilibrium position. Two, since it has moved from A to B, then the velocity, we have maximum velocity, and since it has maximum velocity 3, it has maximum kinetic energy. Don't forget, these are the 3 points that we need to know. Under this point B, the pendulum will be at equilibrium position. 2, has maximum velocity and has maximum kinetic energy. Let's come back here again. Since the pendulum will move to and fro from A to B, B to C, and back from C to B, and from B to A again. Then at point A and C now, that is number 4, it will have maximum acceleration. It will move from A to B, from B to C, and back from C to B, and from B to A again. So at A and C now, the pendulum will have maximum acceleration. That is about the movement of this simple pendulum bulb. Since we said at A, then we have maximum PE. At B, we have maximum kinetic energy. And at C, we have maximum PE also. It means the energy transformation in this mechanical system will be from PE to KE, and KE to PE, and PE again to KE, all along like that. So from there now you can now see that the energy, if you obey law of conservation of energy, now be equal to the magnitude of PE will be mgh, then equal to half mv square equal to mgh again. So the energy is the same at any particular point. Let's take this one as example 1 under this vibrating simple pendulum. The question goes thus: a simple pendulum consists of thin string of negligible mass with a steel bulb of mass 400 grams attached at one end. The length of the pendulum is 100 centimeters. If the pendulum is displaced slightly through an angle of 30 degrees with the vertical and release, then calculate 1. PE of the bulb, 2. Speed of the bulb when the kinetic energy is greater. G is equal to 10 meters per second square. Let's write out the parameter for this question. Mass of the pendulum M is given as, that is 400 grams. Then the length of the pendulum L is given as 100 centimeters. Then the angle theta is given as 30 degrees. And G is given as 10 meters per second square. Let's put it into draw so we can understand it better. Let's say this is the pendulum. This is the equilibrium position. The angle of displacement is 30 degrees to the horizontal. 30 degrees, let's say this is the bulb. According to the question, this is length of the bulb, 100 centimeters. This is the angle, 30 degrees. Now, from there now, when it be displaced, so we are going to add this place as our height. This is the vertical distance. First question says you calculate PE, and mind you, PE is equal to mgh. That is mass multiplied by acceleration due to gravity multiplied by height. And mind you, the height of this pendulum, according to the question, is from this point to this point. That is from here to here. That's the height. So we need to calculate the value of this split. And mind you, from what we are looking at the board, so we can now see that this our L is length of the pendulum, and from there now we can now say that from here to here our H will be equal to L minus Y. If you take it like that, that is, if this thing is in equilibrium, then the length of this pendulum is 100 centimeters, but the height will be deducted from the value of Y. Now the next thing is to calculate the value of Y, so that we can now subtract it from the value of this L given. So we can now say that this place is adjacent to this angle, and this place is hypotenuse. And that one will now give adjacent over hypotenuse from mathematics. So to find y now. So that one will now give us cos 30 degree is equal to y over L. That is adjacent over hypotenuse. So y now will be equal to L cos 30. And from there now we are going to have 100 cos 30 is 0.866, 0.866. So therefore our our y now will be equal to 100 multiplied by 0.866. Now will be equal to 86.66 centimeter. Once we know the value of y now, then we can now say our h now be equal to L minus y. That is 100 minus 86.66. And the answer for h now will be equal to 13.4 centimeter. That's the value of h. So now, once we know the value of h now, then we'll be able to calculate the potential energy, which is equal to PE equal to mGA. So you can now say, therefore, PE now will be equal to mGH. Now, we need to convert our H to meter, because G is given in meter per second square. So this one will now give us our mass is given also in gram. So we need to convert this one also to gram. So 400 gram, then divided by 1000. So that will be 0.4 kg. And 13.4 centimeter. Convert to meter. That one will now give us divided by 100. That is 0.134 meter. So apply all this one. Now we are going to have 0.4 multiplied by 10 multiplied by 0.134. Now the potential energy at that position of the ball will be equal to 0.536 joule. That is the potential energy. To calculate the second question, that is the speed of the ball when the kinetic energy is greater. Speed when Ke is greatest. Now, according to the diagram, the PE will be greater when all the potential energy is transformed or converted to kinetic energy. That is, Ke will be greater when PE has been transformed to kinetic energy. That is when Ke is equal to PE. So, and the magnitude of the Ke is half mv square. That is equal to PE. And what the value of PE here is 0.536. So we are going to have 1 over 2 mv square is equal to 0.536. Mass is 0.4. So we are going to have 1 over 2 multiplied by 0.4 multiplied by v square is equal to 0.536. So this one will now give us 0.2 multiplied by v square is equal to 0.536. So our v square now is equal to 0.536 divided by 0.2. Now v square will be equal to 2.68, and the square root of v will be equal to square root of 2.68, and the final answer will be equal to 1.633 7 meter per second. That's the velocity or speed of the bulb when the kinetic energy is greater. That is for example 1. Now let's take this one as example 2. An oscillating pendulum has a velocity of 2 meters per second at equilibrium position O, according to the question, at the velocity at the point P. Using the diagram below, calculate the height h of P above O. This is the diagram. As the velocity at point P, using the diagram below, calculate the height h of the P above O. G is given as 10 meters per second. Let's write out the parameter within the question. Velocity is given V as 2 meters per second. Then acceleration due to gravity, G, is given as 10 meters per second square. Now the question asks us to calculate h, which is the height of the pendulum from P above O. Now to calculate this one, mind you, as I said in the first example, that the pendulum will have its greater kinetic energy, or we have its velocity when the kinetic energy is greater. It has its velocity when the kinetic energy is greater. And the kinetic energy will be greater when all the potential energy has been converted or transformed to Ke. So therefore, we now say P must be equal to Ke. And what the formula for P? That one will be mgh is equal to that of kinetic energy half mv square. Now from this formula now, the question says we should calculate h. M is the same. So we are going to, M will cancel and we are going to have gh will be equal to half v square. Mind you, this one will now give us 2gh is equal to v square. Already v is given. So we are going to have 2gh is equal to, that will be 2 square. So 2gh is equal to 4. We need h, and at the same time g is given. So our h now is equal to 4 over 2g. Then which is equal to 4 over 2 multiplied by 10. So our h now is equal to 4 over 20. So h, according to the question now, will be equal to 0.2 meter. That's the value of h of P above O. Let's take this one as example 3. A simple pendulum has a potential energy of 300 joule at the point of maximum displacement. If the mass of the pendulum bulb is 50 kg, what will be the displaced height? Now, G is given as 10 meters per second square. From this question now, P is given. Solution. P, that is the potential energy, is given as 300 joule. Mass of the bulb, M, is given at 50 kg. Then acceleration due to gravity is given as 10 meters per second square. So we now have to calculate the displaced height. And you know that P, the magnitude of P, is given as mgh. Now in this question now, we have to calculate H. Potential energy is given. So that one will now give us 300 is equal to 50 multiplied by 10 multiplied by 8. So this one will now give us 300, which is equal to 500 H. H now be equal to 300 over 500. So H now is equal to 3 over 5. And 3 over 5 will give us is 0.6. Then the height will be 0.6 meter. That is the displaced height will be equal to 0.6 meter. This is convenient point to stop for today, and I believe we've done enough justice on this topic, that is energy transformation in mechanical system. But if you still have any question based on this topic or in any topic in visit, as I always say, please, you are free to ask your question under the, make use of the link used under the channel. And don't forget, if you are just joining us, please try to like, share, and subscribe. Thank you very much.